Remember that all epidemiologic studies, even the gold standard, are subject to error, and error makes it harder to infer causality because it introduces other possible explanations for the findings. You've seen two important sources of error in analytic epidemiologic studies: reverse causation and confounding. Epidemiologic studies are also susceptible to a big category of errors called bias or systematic error. Systematic error is when you're trying to get at the true value or the target, but you end up with estimates that differ from that true value in a systematic manner. Systematic error differs from random error, which is when you're trying to get at the true value or target, and you end up with estimates that differ from the true value in a random, not systematic manner. There are two different kinds of systematic error: selection bias and measurement bias. Selection bias is when the procedures used to select participants into a study bias an estimate in a systematic or non-random way. One example of selection bias can occur in case control studies. Remember that in case control studies you've recruited two different samples of participants, one sample with the outcome you're interested in, the cases. In this case, let's say people with stomach ulcers that you identified through doctors' offices, gastroenterologists who specialize in digestive diseases. And one sample without the outcome, or the controls, people who don't have ulcers. Then you ask them about their exposure in the past. But what if you also got your controls through the same doctor's offices? Those patients didn't have ulcers, but it's possible that they had other digestive conditions that made them stop drinking coffee. So when you compare cases to controls, you'll see a big difference in coffee drinking. And it's not because coffee caused ulcers, even though that's what it might look like. This form of selection bias is called control selection bias. Selection bias can also happen in longitudinal studies. It's typical for longitudinal studies to lose participants over time. But what if coffee drinkers who never developed disease were more likely to grow tired of the study and to be lost to follow-up? So when you compare coffee drinkers to non-drinkers, you'll see a difference in occurrence of stomach ulcers that was not because coffee caused ulcers. This is a form of selection bias called attrition bias. Both control selection bias and attrition bias are examples of selection bias, in which the procedures used to select participants into the study can bias estimates. The second kind of systematic error is measurement bias. Measurement bias is when flawed measurement biases an estimate in a systematic or non-random way. An example of measurement bias can occur again in case control studies. Remember that case control studies are retrospective because you're asking people to remember something from the past. One thing that could happen is if cases remember their exposure differently from controls. So when you compare cases to controls, you'll see a difference in coffee drinking because of a difference in recall, not because coffee caused stomach ulcers. This is a form of measurement bias called recall bias. Another type of measurement bias can occur in any kind of study. With observer bias or interviewer bias, the researcher ends up collecting data, whether consciously or subconsciously, that they expected to find. This type of bias can be mitigated by training interviewers to use standard procedures. Both recall bias and observer bias are examples of measurement bias, in which flawed measurement of either the exposure or the disease can bias estimates. So these are some of the major sources of error in analytic epidemiologic studies. They make it harder to infer causality because they introduce another possible explanation for findings. Critical evaluation of epidemiologic studies is based a lot on understanding which study designs are vulnerable to which types of error, which is something to practice next.